Okay, so as I said in class, since we kind of ran out of time, I wanted to actually just record a straight video of me going through the unit overview. Again, this is the bright orange sheet. I put a link to it in the description for this video here on YouTube, so just click the link if you can't find your own. But otherwise, let's start with the left-hand side. So atoms form bonds with other atoms to achieve a more stable state with lower energy, right? Bonding makes you happy. Happy means you have less stress. You are in a state of lower energy. The type of bond formed depends on the amount of attraction. All right, and it's the amount of attraction between a nucleus and the valence electrons. And the other term for that from the previous section is electronegativity, which I typically abbreviate in here as EN because it's a long word to write. Okay, so the difference in electronegativity values and the types of atoms involved determines if a bond is metallic, ionic, polar covalent, or non-polar covalent. Now we're going to go through those different types of bonds. So which type of bonds consist of an electrostatic attraction between cations and anions? Well, that alone should tell you that that is an ionic bond. Okay, and ionic substances form a crystal. And the other part of that word, which we didn't use in class, is called a lattice, but ionic compounds are crystals. This is what I said about salts and things like that. And those crystals are alternating cations and anions, and there's just a whole lot of attraction there. So further on down on this side, so which type of bonds consist of the attraction of a nucleus of one atom for another atom's valence electrons? Well, that description right there, right, attraction, we're talking about two different things, that's a covalent, because that description right there, that is sharing. That's what we mean when we're talking about sharing. Covalent substances form distinct units called molecules. All right. And you should recognize that this is stuff we've written down on those doodle notes on that summary chart. That's where this information is. All right, which type of bonds consist of the electrostatic attraction of the nucleus of one metal for the blank held valence electrons of another metal? Well, I'm talking about two metals. So that's going to be the metallic bond. And the valence electrons there are what we refer to as loosely held, right? This gave us our sea of electrons. Okay. And metallic substances consist of free-moving electrons. So let's do the right-hand side before we turn it over onto the back. Okay, so here, the electronegativity differences for each type of bond. So for ionic, we're not looking for actual numbers here. You just need to know that this is a large difference. All right, that's what we did in that types of bonding Pogel packet where we did the addition and the averages and all that sort of stuff. From the polar bear packet, we learned that polar covalent, well, these have a medium difference, right? They actually are different. They're not different enough to actually yank electrons off, but they're pretty different, right? You've got a polar bear and a penguin. They are not evenly matched. But if you have a non-polar covalent, well, this is like the two penguins or the two polar bears. So you have a small or non-existent difference. Existent. There we go. Difference in those electronegativities, meaning they're almost the same. And looking at the type of elements that make each kind of bond. So an ionic, we said that this was a metal from the left-hand side of the periodic table, and a non-metal from the right-hand side, remembering that that nonmetal is also hydrogen. For our polar covalent, this is two different nonmetals, but again, that also includes hydrogen. And our nonpolar covalent is often, not always, but often two of the same non-metal. All right, so that would be things like F2, O2, H2, those kinds of things. Our metallic is just metal atoms, all right, of any sort. Metal atoms are going to make metallic bonds, and it doesn't matter if they're the same type of metal atom or different. Okay, so moving on to the back page. So for the back page, finishing up the bullet point from the front, it says metallic substances consist of free moving electrons surrounding metal atoms of all the same. Turn it over type, which gives you a pure element, or of different types. So when you have a metallic bond that actually has different types of metals in it, it's called an alloy. All right. And then let's see here, properties of ionic substances. Again, this is from your summary chart on your doodle notes. Properties of ionic substances include high melting points and boiling points, right? I said you can't just melt salt, but they do conduct electricity when they're molten or they're dissolved in water. They do dissolve in water, right? But covalent substances are kind of opposite. So they have low melting and boiling points. They don't conduct electricity, right? They don't dissolve, not soluble, those sorts of things. Metallic substances are always going to conduct electricity, but they'll do it as solids. And they're also malleable and ductile. And then these last two bullet points, if we have an unbalanced attraction and an unequal amount, right? Unequal, that was our polar covalent. But if I have a balance here and I am equal, that is my non-polar covalent. And then the last few things here on the right-hand side. So the behavior of the electrons in each of these bonds, well, when I'm talking about an ionic, I have a metal transferring to a nonmetal. So I'm going to say a transfer of electrons to form cation and anion attracted together by opposite charges. And you do always have to remember it is the metal giving to the nonmetal. So for a polar covalent, we say that we have an unequal sharing. All right, the key there is the unequal sharing of electrons, where the more, and I'm going to say E in there for electronegative element, pulls electrons closer, making what we call a dipole, right? That was that partial positive or negative thing. Non-polar covalent is going to be the opposite. So we have an equal sharing of electrons, where each element has an equal attraction for electrons. And lastly, metallic. So this was every metal atom has an attraction to the C of electrons that are all around. And that's it. So the rest of this sheet we will finish after we finish this next section.